Welcome, and thank you so much for taking the time to watch through this video to get that critical information you're going to need for the AP exam. So in this video, we're just going to be talking about the multiple choice associated with Chapter 1, okay? Because there are some big ideas from Chapter 1 that frequently pop up on the AP exam. So let's get started with the ideas that commonly pop up. So first, I understand measures of center and can compare the mean and median of a distribution. So remember, the mean is the average of the data set, while the median is the midpoint where half the data is below it, half the data is above it. For the distribution that is symmetric, the mean and the median will be about the same. If the distribution is skewed, the mean will be pulled towards the tail, while the median remains relatively ineffective. Skewed data is best described by the median and IQR, since they're resistant to outliers, while symmetric data can be described by mean and standard deviation. So the National Park Rangers keep data on the bears that inhabit their park. Below is a histogram of the weights of 143 bears measured in a recent year. And they want to find the interval that the median lies in and that the mean lies in. Because again, you can't find an exact value from a histogram, but you can find which category it's in, right? Which interval it's in. So if the median is the exact halfway point, well, what that means is we're looking for 143 divided by 2. It's 143 divided by 2. So we're looking between these 71st and 72nd data point, right? We're looking in between there. So let's find where that is. Okay, so I'm going to count up the data in the bars until I find where this positioned data point is. So for example, this first bar probably has about 6 in it. This bar, I'd guess maybe, we'll say 17. So together so far we've accounted for 23 data points, but we're not quite there yet. This one, I'd say probably has around 27. Add 27 more, now we're sitting at 50. Add, I'd say that's maybe what, 34? Now, in these bars right here, we've accounted for 84 of the data points. So that means while we can't tell exactly what the median is, I can tell you that the median is in this bar right here, right? So again, for histograms, that's the process you go through to find the median. You just find which position you're looking for and then find which bar that position is in. So here, the way that it's laid out, the one that's above 160 is actually spanning from 140 to 180, right? It's spanning beyond that. So here, our median is going to be between 140 and 180. So that's going to rule out C and D. And actually E or D as well. I'm sorry. So all of those had the wrong thing. So I'm not even going to worry about those. The next step comes from finding the mean, okay? The mean is going to be pulled towards the tail, right? So the mean is going to be a little bit higher than the median. Now, just be careful that you don't pull it too far. So here there's no good exact measurement to find it. You just want to make sure you're not pulling too hard on it. So here I think A is going to be the most appropriate answer. It has the right median and then shows that the mean is pulled a little bit above it. For number 2, a set of data that has a mean that is much higher than the median. Which of the following statements is the most consistent with that information? So the mean being larger than the median, that means your tail is being pulled up, right? It's being pulled upward towards the tail on the right. Now remember, when we're talking about skewness, the skewness describes where the tail is. So if you're noticing the mean is much larger, it's being pulled upward by the tail, that's going to be skewed right. Number 3. So number 3, the frequency table below summarizes the times in the last month that patients at an emergency room in a small city hospital waited to receive medical attention. Which of the following represents the possible values for the median and mean wait times for emergency last month? All right. So again, we're looking for possible values for each of those. Now, in terms of median, this works the same way. So I added up all of those data points. We're talking about 140 data points, okay? The median is going to be the exact middle of that. The median is going to be the exact middle. So take that divided by 2. It's going to be the 70th data point. Well, technically in between the 70th and the 71st data points. Okay, so the first thing we're going to do is find that median. All right, so I start with 5, add 24. Well, together that only accounts for 29 data points, so not quite enough. So I'm going to add 45 more to that. Ooh, all right. So in this part of my table, and I'm sorry I can't move the screen. My computer's not working very well. That is going to be the interval that my median lies in. So my median is at least 20, but less than 30. Okay, so at least 20, but less than 30. So that's going to be my median value. Now, if you look at that distribution, okay, you look at the distribution, it looks slightly skewed right, doesn't it? The values up above are getting a little bit smaller, right? So if this is slightly skewed right, again, we'd expect the mean to be a little bit bigger than the median. So let's look at all of the values that we're saying are possible, okay? We talked about having a median above, above 20, but less than 30. Okay, so that rules out above 20, less than 30 is going to rule all of those out. We also talked about because of the general shape, we're seeing it look slightly skewed right, that we'd be expecting the mean to be slightly larger than the median. That would leave us with letter B. All right. Now let's talk about another key thing from chapter 1 was a discussion of outliers. So to determine if a data point is an outlier, we use a 1.5 times the IQR rule. The rule says if the value is below that and above that, it is considered an outlier. So a poll of 38 AP statistics students says, how many hours a week do you spend studying for statistics? The results are summarized for the computer output below. If a box plot were constructed, which data points would be marked as outliers? Now notice they're only asking about greater thans, so we only really have to worry about the upper end of this thing, right? If I calculate that and I have any values beyond it, then that means that those would be deemed as outliers. So Q3 is 12 plus 1.5 times the IQR. Now the IQR, remember, IQR equals Q3 minus Q1. So 12 minus 5, so the IQR is going to be 7. So if I do that calculation, 12 plus 1.5 times 7 gives me 22.5. So any values greater than 22.5 are going to be deemed as outliers. Standard deviation is the average variation of the data set from the mean. The more spread out from the mean it is, the higher the standard deviation. The interquartile range is the spread of the middle 50% of the data, and as we just talked about, it represents Q3 minus Q1, or if you're thinking graphically or visually, it is the box and the box and whisker plot, okay? So which of the following sets has the smallest standard deviation? Which has the highest? All right, well, smallest would be the ones where it is the most near the center. So here the center is 4, so that one is going to have a very small standard deviation. It has a lot of the data around the center, not so much at extreme edges. The one with the largest is going to be the opposite of that. A large standard deviation comes from having almost nothing near the middle and everything out at the extremes. Okay, so 3 is the smallest, 2 is going to be the largest there. So again, that's how you can talk about average, or talk about standard deviation and spread. All right, now the next one, again, I apologize, it's not letting me move my screen down any further. So we're just gonna have to make do with you looking at your packet. It says here 2 random samples of students are chosen, one from taking the AP exam or AP statistics class and one from those not. The following back-to-back STEM plot compares GPAs. All right. Which of the following is true? Okay, so here, which of the following is true about the ranges and standard deviation? All right. So range and standard deviation. All right. Well, range is pretty easy, right? Range is simply just talking about the lowest value or the biggest value and subtracting off the lowest. So for AP, the range would be 4.0 minus 2.3, correct? And that would give a range of 1.7. Largest value minus the smallest value. Non-AP, we're seeing 3.8 minus 1.8. That's going to give us a range of 2. Okay, so first off, it looks like the non-AP students have a larger range. Something else to note. Here, notice the AP students have kind of a symmetric shape to it, right? Where non-AP students are skewed. Skewness typically adds to the standard deviation. Something that is skewed is likely to have a slightly larger standard deviation than something that is not skewed. So in this case, I would argue that I think that the non-AP students, that second data set is greater for both because of that skewness that we're seeing in the data. Number 6. Number 6, the parallel box plots below show monthly rainfall summaries for Liberia, West Africa. Which of the following months has the least variability as measured by interquartile range? Interquartile range, again, the interquartile range visually is going to be the box itself. Okay, so we're talking about the box itself. Which one has the smallest? Between January, February, March, May, or December. So if we're looking at this one, January, February, March, May, it's right here, or December, again, least variability is measured by the IQR, so which one has the smallest box? Well, here, I would argue, I think December has the smallest box. So in terms of interquartile range, it's going to have the smallest. All right, the next learning tracker. So this one is a huge, huge idea, okay? Being able to discuss box plots. I see this pop up all the time on multiple choice questions. So the segments of a box plot are made from the quartiles and pieces of the 5-number summary, and each segment contains 25% of the overall data. So remember, the length of the segment has nothing to do with the amount of data in it. All it shows is that the data within it is more spread out. Okay, so you're going to be very, very careful that you're not trying to compare the amounts. The lengths of the boxes themselves have nothing to do with the amount of data in it, simply the percentage or the how spread out that 25% of the data is. So number 6, the following statistics provide a summary of the distribution of average SAT score for the 50 states. About 25 states have an average SAT scores that are, all right, so, well, there's 50 states, so 25 states. All right, isn't that half? So we talked about that 5-number summary. So, oh, min, Q1, median, Q3, maximum. So in between any one of those, so in between here is 25%, 25%, 25%, 25%. Well, now we're looking for 50%, right? 25 of 50 is 50%. So what we're looking for is an interval that spans across 2 of these things. So for example, from the minimum up to the median, that would contain 50%. That would be reasonable. From Q1 up to Q3, from the median up to the max, okay? So we're looking for one of those ranges. So less than 895. So I'm looking at letter A. Well, less than Q1 is only 25% of the data. So that's not what we're looking for. Letter B, less than 990. Well, less than 990, that's Q3. That would be 75% of the data, not what we're looking for. Between 895 and 990, so between Q1 and Q3, that is what we're looking for. So the answer to this one, we're talking about letter C, between 895 and 990, because that's the only one that spans from 50% of the data, spans between 2 of these lengths, 2 of these segments. Okay? And continuing right along. The box plot below shows the reaction times in milliseconds for 2 groups of subjects who were exposed to either threatening or non-threatening stimuli. Which of the following statements is true? The median reaction time of the group exposed to non-threatening stimuli is less than that of the group exposed to the threatening. All right, so it's hard to see, but there is a line in the middle of each of those boxes, right? That line inside the box represents the median. Well, non-threatening is less than threatening. That's not true at all, right? If we're noticing here, the threatening one is around here. This one is around here. So A, not right. The range of the group exposed to the non-threatening group is less than that of the group exposed to the threatening. So range, we're talking about overall distance. So range is from here to here, here to here. I wouldn't say that's less than. I'd say they're actually about the same, right? Those ranges are relatively equal. So I would say no, that is not true. The first quartile of the group exposed to the threatening group is greater than all the reaction times for those of threatening. All right, so here, the first quartile of the non-threatening, that would be this red, I'm drawing red here. It's greater than all reaction times for the threatening. Well, no, because all of these are above that. So again, C, not quite true also. Half of the reaction times for the group exposed to non-threatening are greater than all of the reaction times. Well, this time half is referencing the median. And I'd say that's true. Notice the median. The median for the non-threatening group is greater than all of the ones for the threatening group. So I would say here D is true. The median is greater than all of the values of the threatening group. Now, even if you think it's D, again, you're going to have enough time to go back and really check your answers. Think about your answers. So here, let's consider E just to make sure that we've made the right choice. There were more subjects exposed to non-threatening stimuli than threatening. Well, again, you can't tell that in a box plot. It tells you nothing about the amount that are in each group, okay? So this is something you should not be saying. Box plots don't compare amounts, they compare percentages. All right, number 8, the travel time. The travel miles claimed by weekly expense reports on sales personnel at a corporation are summarized in the following box plot. Which of the following is the most reasonable conclusion? The mean and median numbers of travel miles are roughly equal. I would say absolutely not, right? This looks severely skewed left, which means that they would not be the same at all. The mean number of travel times is greater than the median. Well, again, I would say absolutely not. The mean is going to be pulled to the tail. You notice the tail is going to be leftward where all those outliers are. So again, not true. Most of the claimed numbers of travel miles are in the 0 to 200 group. Well, 0 to 200 from here to here, well, that doesn't cover 50% of the data, right? The median is up here, which means if you're only spending up to 200, you're talking about less than half of the claimed amounts because you're below the median. So I would say C is also false. Most of the claimed numbers are from 200 to 240. 200 to 240, this I could say is true, okay, because that is spanning over 2 segments. You have the segment here, which would be 50%, and then a little bit more. So I would say D is a correct statement, right? You are covering over half of the claims in that little interval that you're showing. E, the left and right whiskers contain the same amount of values from the set personnel travel time. That is also false, and let me show you why. So typically you're right, the whiskers should, but in this case you have these outliers. So those outliers are taking away from the whisker. So the left whisker actually has less than the right one because you've removed a couple data points as outliers. Okay, so that would be true if it wasn't from the fact that there are outliers that have been pulled out of that whisker. Number 9, again, I'm sorry, I can't move my screen to be better. The medical researcher studying the effects of duration of 3 over-the-counter pain relievers obtains the following box plots from 3 equal-sized groups of patients, one group using each of the pain relievers. So, which of the following is a correct statement with regard to comparing the effective durations in minutes of the 3 pain relievers? All right, all 3 have the same interquartile range. Well, if you look at them, that's not true. Those box lengths are not the same. And remember, the interquartile range is the length of the box. So I'm going to rule that one out right away. That is not true. More patients had over 210 minutes of pain relief in group 1 than in either of the other 2 groups. All right, so more patients had over 210 minutes of pain relief in group 1 than either other one. Now, I would say that's actually false. That's the opposite of what we're seeing because groups 2 and 3 have a larger portion of their whisker above that. Okay, so I would say B is also false. You're, on, you're only seeing, wait. Sorry, I had to pause it there for a moment just to make sure I was going to explain it the way that I really want to. Um, so looking at this carefully, all right, I was looking at actually the wrong value before. So here, for 210, notice 210 represents approximately the median for the first group, but Q3 for the other groups. So implying 25% of the data from groups 2 and 3 are above 210, while 50% of the data from group 1 is above 210. But you're here talking about more patients. And remember, I had cautioned you about doing that, right? About comparing amounts. But if you look at the directions, it says all of them were equally sized. So each of these box plots actually represent the same amount of people. So in this case, that is actually the rare exception that when you know that your total is the same for each one, you actually can compare amounts. And so again, in B, you're noticing that 50% got better or saw pain relief for longer than 210 minutes. The other ones, only 25% saw above that. For these other ones, these I don't like because those aren't at nice markers, right? 210 is at a nice marker. It was Q3 in the median. Those ones don't fall on a special marker, so it's much more difficult to make any interpretation of something that is not at one of the benchmarks of the 5-number summary. And E, for group 2, while group 2 is symmetric, it's too strong of a statement to say that that makes it normal, right? Those are very different things, and that is too strong of a statement to make. If it had said symmetric, yes, that would be great. However, that's not what it said, and therefore you can't mark E as correct. All right, moving on to our next one. So stem and leaf plots. So a study at 35 large city schools gives the following back-to-back stem plot of the percentage of students who say they have tried alcohol. Which of the following does not follow from the above data? So we have from the 1995 school year and the 1998 school year. So letter A, in general, the percentage of students trying alcohol seems to have increased between the 2 years. From that, I would say that's probably true. You're seeing your peak at higher for the 1998 school year, the 1995. You see a higher minimum and a higher maximum. So I would say A is actually a true statement. That does appear to be the general trend. The median school alcohol percentage among the 35 students increased from 1995 to 1998. I'm sorry, that is a typo. That should be 2. And yes, that is, again, the trend that we're seeing. We notice the peak is going upward. So if the peak amount is going upward, the min and the max are moving upward, that would imply that the median is likely moving upward too. If you wanted evidence of that, again, you could actually find what the median is. That 35, so we have 35 data points, 35 divided by 2, so we'd be looking for the 18th data point. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if you wanted to actually find the medians, you could also use that as evidence. Otherwise, again, I think just eyeballing it would have been enough to convince you that B is a true statement. The median did increase. The spread between the low and the highest percentages decreased from 1995 to 1998. Well, again, that's easy because here for 1995, 90 to 12, the range is 78. Now 92 minus 31. So yeah, we did see that spread in general decrease. For both school years, in most of the 35 schools, most students said they had tried alcohol. And again, most students, that would come from having a median that is above 50%, right? So a median above 50%, well, we already kind of showed ourselves that both of them are. 1995 had a median of 59%. 1998 had a median of 73%. So again, both of those were over half. So yes, over half of students, we believe, are trying alcohol. The percentage of students trying alcohol increased in each of the schools between 1995 to 1998. Now that I would argue is too strong of a statement, okay? And let me show you why I think that's too strong of a statement. So let's say maybe this school that had 61 here, maybe that particular school dropped down to 56, right? So every single school, we don't know that every single school went down. You don't know how these schools relate to each other. Again, this 61 might be the 56 here, or it might be the 70 or the 67 over here. You don't know exactly which one pairs to which, so you can't definitively say that every single school increased. All you can say is the general trend was increasing. All right. So segmented bar graphs. So remember, you cannot make statements about amounts within a category between bars, only within a bar. Between bars, you should really only be comparing proportions, again, unless you know that each bar has exactly the same total. Okay, so here for number 10, a study on school budget approval among people with different party affiliations resulted in the following cemented bar graph. Which of the following is the greatest? Number of Democrats who are for the proposed budget, number of Republicans who are against the budget, number of independents who have no opinion on the budget, all are equal, or the answer is impossible to determine without more information. And again, I would say that it is E. It's impossible to determine without more information. Again, what we would be looking for is we'd be looking for the idea that to say whether they're equal or not, we need to know that it's the same amount of people in each category. You can't compare amounts of people, number of people, without knowing that the total was the same. So E. Another learning target, I can represent data with different graphical displays. So we're transitioning between different style or different displays, box plot to stem plot to histogram to dot plot. Look for distinguishing features such as outliers, shape, and median. Okay, so the results for a recent test are displayed in the histogram below. Which of the following box plots represents that data? All right, so again, we're looking for distinguishing features here, right? So first, I don't like E because I don't think all three of these would be deemed as outliers. This one right here is still relatively close to the bulk of the data. I find it very difficult to believe that that would be considered an outlier. Now, at the same time, I also find it just difficult to believe that none of them would be deemed as outliers, right? Those 2 points up above do seem pretty off of the general trend. So I would say likely we're talking about A or C, because I think both of those more extreme points are going to be deemed as outliers. Now, let's talk about how to determine the difference from the two that are left. All right, now, while it's really difficult to see the way that this copied, I apologize for that. On my copy, it looks like the median here is a little bit lower than the median of this one, okay? So basically it's the idea, which is a more appropriate median for it to be in, okay? And I think A, and again, I apologize, you can't very well see that in yours. I think A has a more appropriate median, okay? I think it should be a little bit lower. It should not be way up there at 80. Okay, it's going to be closer to that peak. So again, that's how I would go through this. Discuss the median, outliers, and this and that to see which one fits the best. And finally, I can use the one variable stack calculator command. When you're given a set of data, you can use one variable stack command to get information such as a 5-number summary, mean, standard deviation, etc. about the data. All right, so here, again, my piece of advice, if they just give you data like this, you can very easily go put this data into a list. So I'm going to go input all of this into a list. So I'm going to clear out what's there, then type all this in. So 145, 139, 126, 122, 125, 130, 96, 110, 118, and 118. So let me just check to make sure I have all those in right. 145, 139, 126, 122, 125, 130, 96, 110, 122, 118. Beautiful. All right, so the first one, the student with an IQ of 96 is considered an outlier by that rule, by the 1.5 times IQR rule. So let's see here. I'm going to run my one variable stat. The IQR rule, oh, well, we need the IQR. So I'm going to scroll down. Remember, IQR is the difference between those two. So what we're curious about for a lower bound is 118 minus 1.5 times the IQR. I see a difference of 12 in there, okay? So if I calculate that, 118 minus 1.5 times 12, I get 100 as my lower bound. So anything less than 100 would be deemed as an outlier. So I would say A is a true statement. That is an outlier based on that 1.5 IQR rule. So here A is not, it's true, so it's not what we're looking for. The 5-number summary of the 10 IQR scores is, well, again, we could just look at the calculator for that. So min would be 96. So actually this right here, that is your 5-number summary. And again, that does match what B is saying. So if it matches it, if it's true, that means that it is in fact not what we are looking for. If the value 96 were removed from the data set, the mean of the remaining 9 scores would be higher than the mean of all 10. Well, again, yes, that would be true. We talked about 96 is an outlier. So if you remove that, yeah, you move the bottom point, the least point, it is going to shift the rest up. If 96 were removed from the data set, the standard deviation of the remaining 9 IQ scores would be lower. Again, that's true. If you remove an outlier, that average variation would decrease, would go down. If the value 96 were removed from the data set, the IQR would be lower. Well, outliers don't impact the IQR. So E, I don't think that would have an impact on E. It wouldn't change that middle 50% of the data. Again, the IQR is unaffected by outliers. It wouldn't have an impact at all to remove an outlier. So E is the one that does not follow, which means E is the answer that we are looking for. And that is actually it for this video, because if you notice, next up are the FRQs, which is something we're going to discuss together. Okay, that's going to be the next lesson. So after watching this, now again, please go do those practice problems. Okay, get some practice on your own of these skills, and I'll have my answer key up online for you to check your answers against.